Today we will study the remaining types of operating system. Under the types of operating system, we had already covered various types of operating system. Today we will study the types of operating system on the basis of users. Some of these widely used operating systems are single user operating system, multi-user operating system, multitasking operating system, and multi-processing operating system. Now we will discuss things about or key points about single user operating system. As name suggests, operating system that is designed for one user to effectively use a computer at a time is called single user. In single user operating system, only one user is allowed to use computers at a time. The examples of single user operating system is disk operating system, DOS, and previous version of Windows like Windows 3.0, Windows 6.0. These operating systems are single user operating system. It means only one user can access at a time. Then the next type of operating system is multi-user operating system. As its name says, multi-user, it means more than one user is allowed to use the same computers at a time. This type of operating system allows multiple users to simultaneously use the system, and the processor splits its resources and handles one user at a time, and the processor is responsible for dividing or splitting its resources in different groups, and one process or one users use at a time. Then some network systems utilize this kind of operating systems, or we can say this type of operating system is used at a network at the level of network operating system, where multiple clients are connected to one server. The examples of multi-user operating system is Unix, Linux, Mac. These are the multi-user operating systems. The next one is multitasking operating system. In this type of operating system, several applications may be simultaneously loaded and used in the memory. The basic difference between multitasking and multi-user operating system is in multi-user operating system, more than one user is connected to one of systems. But in multitasking, more than one programs or more than one applications is running at a time, or we can say loaded in memory at a time. More than one applications or more than one program is loaded in memory at a time. But in case of multi-user, more than one users are connected to the systems at a time, but at a time one program or one user request is accessed at a time. But in case of multitasking, more than one programs is loaded in memory at a time, while the processors While the processor handles only one application at a particular time, it is capable of switching between the applications effectively to simultaneously execute each applications. The Windows operating system is the examples of multitasking operating system. The operating system we are using is multitasking operating system. As we see, we can also observe at the same time we are opening, we are accessing the browsers, playing videos, playing multimedia applications, or at the same time we are working on doc files, Microsoft Office. So such type of applications are multitasking applications, and the such type of services provided by the operating system is called multitasking operating system. Then multiprocessing operating system. In multiprocessing operating systems, a system with more than one CPU in close communications, also called multiprocessing systems. Till now, in single user, one processor is there. In multi-user, again one processor is there. In multitasking, again one processor is there. But in multiprocessing, more than one processor is there. That's the difference. In multiprocessing, more than one processor is there. And these processors are tightly coupled. Tightly coupled means they are not easy to connect or disconnect to the systems. The basic advantage of multiprocessing operating system is increased throughput. Throughput is the actually number of instructions executed per unit of time. How many number of instructions are executed per unit of time is called throughput. So after the using of multiprocessing or more than one processor, the execution times is increased or the execution time is fast. So the number of instructions per cycle is more. Therefore, the throughput of the systems is increased. Then the different types of multiprocessing operating system. First is asymmetric multiprocessing. In this multiprocessing operating system, each processor is assigned a specific task. If n number of processors are connected, then each processor are doing, yeah, each processor is working on different tasks. There is a structure in asymmetric multiprocessing. There is a structure of master and slave concept. The master is responsible for assigning the task and monitoring the process or monitoring the activity of each slabs. So in asymmetric multiprocessing, master processors schedules and allocate works to slab processors, and this type of a structure is suitable for extremely large system. And the next type of multiprocessing operating system is symmetric operating system, symmetric multiprocessing operating system. In this type of multiprocessing system, each processors run an identical copy of the operating system. Many processors can run at once without performance decline. Most modern operating systems support SMP. This is the structure of multiprocessing operating system where more than one CPU is connected and they all are sharing same memory space, or we can say the all connected processors are sharing common hardware. The basic advantage or the major advantage of multiprocessing operating system is increased throughput. By increasing number of processors to get more work once in more work done in less time. If the number of processor is increased, then the number of applications completed within time is more. So the overall throughput is increased. Next, economy of a scale. They can share peripherals, master storage, and power suppliers. Increase reliability. If failure one processor will not halt the systems, only slow down the processing. Suppose we have connected a number of processors and all processors are independent, not depends on each other. It means if one is fail, then it will not affect whole systems. It will affect only the that particular system. So it increase the reliability. It means if failure of one processor, then it will not affect the whole system, but one but the execution time is increased, or we can say it will make slow down the system. Okay, thank you so much. In next class we will study a structure of operating system. uh, till now we have covered introduction to operating system, goals of operating system, services of operating system, and different types of operating system. Till now, if you have any doubts, you are most welcome to discuss with me. Thank you so much.